Imagine you're an architect designing the perfect building. But there are constraints, limited materials, space restrictions, and building codes. Large language models face similar fundamental constraints that shape how we must design AI systems. Today, we'll explore 4 critical constraints that define the foundation of modern AI architecture. Think of these as the physics of the AI world, immutable laws that every system must work within. Constraint number 1, statelessness. Every conversation with an LLM is like meeting a brilliant expert who has complete amnesia. They have vast knowledge but no memory of your previous interactions. This means every single prompt must be self-contained. You can't say remember what we discussed yesterdays because there is no yesterday in the LLM's world. This fundamentally shapes how we architect AI systems. Constraint number 2, context length limitation. Imagine trying to have a conversation through a keyhole. You can only pass so much information at once. Current models might handle 32,000 tokens, advanced ones perhaps 200,000, but eventually you hit a wall. This creates a crucial trade-off. Do you include the entire customer history or focus on the most recent interactions? Do you provide comprehensive documentation or just the relevant sections? Every token is precious real estate. Constraint number 3, training data availability and cutoff. Your LLM is like a time traveler from the past. It knows everything up to its training cutoff date, but nothing beyond. It's frozen in time. This means LLMs can't tell you about yesterday's stock prices, this morning's news, or your company's latest internal policies. They're incredibly knowledgeable, but their knowledge has an expiration date. Constraint number 4, task-oriented prompting. LLMs are like incredibly skilled improvisational actors. They need a clear scene, character motivation, and direction to perform well. Vague requests get vague responses. The art lies in crafting prompts that are specific enough to get useful results, but flexible enough to handle edge cases. It's the difference between asking help me and help me write a professional email declining a meeting due to scheduling conflicts. These constraints have driven the evolution of AI architecture. Just as building constraints led to architectural innovations like flying buttresses and steel frames, LLM constraints have led to specific patterns. The core pattern that emerged is beautifully simple: prompt, context, LLM generation, and enhanced rendering through chaining. This pattern repeats whether you're building a simple chatbot or a complex multi-agent system. The real art, the database design of the AI world, is problem decomposition, breaking complex tasks into LLM-sized pieces. It's like a master chef preparing ingredients before cooking. The preparation determines the final dish. In the database era, success hinged on getting table relationships right. Normalize too much and queries become complex. Normalize too little and you get data inconsistencies. The same design thinking applies to LLM systems. In the LLM world, the equivalent is understanding model capabilities deeply enough to decompose problems correctly. Which tasks should be one prompt? Which need multiple steps? What context is essential versus nice to have? Master context retrieval, and you've solved half the puzzle. Build systems that can find and format the right information for each LLM interaction. This is your data pipeline, your ETL process, your indexing strategy all rolled into one. With deep model intuition and robust context systems, multi-agent architectures become achievable. Imagine agents that hand off tasks seamlessly, each specialized for their role, each receiving perfectly curated context. Consider a customer service system. Agent 1 handles intent classification. Agent 2 retrieves relevant documentation. Agent 3 crafts the response. Each has a clear, focused job with the right context. The future belongs to teams who understand these constraints so deeply that working within them becomes intuitive. Like skilled architects who see opportunity where others see limitation. The question isn't whether these constraints will disappear. They define the fundamental nature of how these systems work. The question is, how masterfully will you design within them? Master the constraints. Design the decomposition. Build the context systems. The age of truly useful AI agents awaits those who understand these foundations.